Hello, everyone. Hope you can hear me fine. Thank you for giving us the opportunity to share our journey at Vizient with AI and ML. And I'm presenting this along with my ML lead and architect, Adam Hasham. So my background is primarily historically been in the data and BI space. And Vizient began our journey in Databricks right around the time I joined Vizient in 2022. And with Databricks, what we have been able to do is provide a data estate based in Delta Lake that is providing our enterprise analytics. And I'll give it to Adam.
Hey guys, Adam Hasham. I'm a ML lead here at Vizient. I have a lot of experience across AI startups, academia, and now Vizient as well. So glad to be here as well.
Awesome. So first, a background about Vizient. So Vizient is a healthcare performance improvement company that historically impacts a lot of verticals. And we typically serve healthcare organizations in various scale, as the next slide will educate a little bit more, where we accelerate the delivery of high-value care. And who we serve is typically we serve very large hospital systems, inpatient, outpatient, ambulatory medical centers. And we serve them in various verticals in both the clinical space as well as the supply management, or what's now called spend management. And we also do custom consulting. And we serve about 65 to 70% of the hospital systems across the country. So, and we provide benchmarking, and our CTO likes to say that we had data science embedded in our solutions before data science was cool. So we've always had 50 to 60 different products that all had some kind of data science embedded into those guided analytics, and we continue to do so. And this architecture slide actually depicts two time frames, I would say. So one before we bought into Databricks, and one which included Databricks, but it was before 2024, I should say. So if you look at the slides, we did have data prep, feature engineering, model training, model serving, and so on, except they were in a variety of ecosystems that were siloed. And each clinical application or supply chain analytic application had their own technologies, had their own processes, and the data scientists and the data engineering teams were basically using process management to get the work done, to provide the analytic insights out of it. So that was the ecosystem that we lived in. And this also included a brief period where we did have Databricks added to our tech stack as well. And the factors that were limiting us during those two time periods, like I said, the first part was, even in the Databricks ecosystem, this predated the Unity catalog days. So we basically have about 60 plus data engineering teams and data scientists involved in some of those applications. And so if data needed to be made available for these various applications, or if they needed to do any kind of cross-domain analytics in a legacy high Metastore ecosystem, that was extremely cumbersome. And then when we started doing Databricks on our own, we didn't have any industry templates or an authoritative CI/CD framework that we could take and kind of customize it for our needs. So we ended up building our own framework, and it was a little bit rigid. And so for any AI or an ML project to basically be done in the ML workspace, they kind of had to follow some very rigid steps, and our data scientist friends partnered with us wherever possible, and some tried to do that. So the adoption was not happening at the scale we preferred. And as most of you experienced, this was pre-2024, 2023, where there wasn't any AI-enhanced collaboration for us to iterate our strategies. So they were all pretty long and cumbersome trial and errors to kind of prove out our strategies, whether it worked or not. So the turnaround time for switching was also longer. And all of this meant that these siloed workspaces, siloed teams, and the fact that the data scientists had their own priorities, the data engineering teams had their own priorities, and trying to make all of that synergized was very hard. So that was the pre-2023 area. And this is our current journey as it goes. And the difference between the previous slide and now would be that, number one, from a data prep and a data store perspective, we are now in a Unity catalog ecosystem. So where we have domain-specific catalogs, and we are trying to centralize our acquisition of our data, both structured, unstructured, and the legacy systems that we have. We do have a homegrown data ingestion framework that syncs to the lake to have the data available all in Unity catalog. And so from that standpoint, for the data scientists, for the most part, for data that's already there, the data is already in Unity catalog. And then we were also very intentional from an AI and an ML ecosystem that we should be providing optionality and be a little bit agnostic. And so we from the get-go, based on the needs of the data scientists, had both Azure ML and Databricks in our stack. And as we started building this out, we also saw that a lot of these initiatives that the data scientists were involved had a generative AI component in their solution. And so we had to make sure that we built up the Gen AI infrastructure to be able to handle that. And we are one of 2 or 3 teams that are contributing to the platform. So at this point, I'll turn it over to Adam.
Perfect. Thank you. So the vision of the AI ML platform is to ship models faster, safer, and smarter with greater business impact across all of Vizient. One thing is that in production, and anywhere you go in production, it's really tempting to focus on the green box here, the AI model. It is the coolest part by far. But in reality, when you get into production, to deliver that business impact, you require the entire system to be super robust. And that includes things like feature extraction, serving infrastructure, and much more. You can see that here on all the white boxes. And without that, the model just will not perform. So MLOps is your backbone, and MLOps is mission critical to perform and to get your business impact. So how do we achieve this vision? How do we ship AI models faster with greater business impact? Well, our idea is we're going to fine-tune to perfection. But we're not going to talk about neural nets. We're talking about fine-tuning our AI deployment excellence standard, optimizing it with each deployment, and then quickly pushing back those learnings right into development to capture that value. So how can you enable this within your organization? Well, that's shown here. You can enable it with your AI model lifecycle strategy, your modeling and deployment best practices, and also your MLOps framework. So if you're starting from zero, you need to start somewhere. And what you need is CI/CD that's tried and tested. But you also probably want project structure and code that's tightly integrated to your platform's technical capabilities. We're really lucky today. A great place to start with this that gives you a lot of a huge jump is MLOps stacks from Databricks Asset Bundles. It's a great place to start because you get sample templated CI/CD pipelines, and you get code templates for a quick start. And this is actually tightly coupled to your platform for system development, model training, and it has definitions for things like pipelines, for model experimentation, and also all the cool new features they're introducing. So at this conference, there's a lot of really cool sessions that deep dive into Databricks Asset Bundles. We won't be doing that today, but we'll show you how to take it to that next level. So one of our early customizations with the MLOps framework was adding pre-commit checks. We started with black for code formatting, and we also included Pilot to enforce code quality. And this ensures that each code commit has a baseline standard, you catch issues early, and you reduce your review overhead. In your organization, you can use this to also enforce compliance with the organization's best standards for coding. And if you're doing this, some pro tips, consider some of these tools here as well. Bandit's great for code security issues, MyPy for static type checking. And the favorite one I'm kind of watching right now is Rough. It's really fast codeliner, and it's built in Rust as well, which is why it's super fast. So today we'll showcase two really cool AI products we have deployed as well. The first is LLM Web Shooter. So this is a really cool AI model. It's a web surfing LLM that automates entity recognition and entity generations for previously unclassified medical products. And the guy who developed that is actually here in the room. He's at the back, Harsha. Mm-hmm. This, right there, yeah. Say hi, Harsha. Mm. There we go, cool. So this model has had immense impact across Vizient. We've seen 80% increase in accuracy to identify these products, and at 8x the speed of what the process we were currently doing. So I guess his favorite number might be 8. But with deploying this model, we also evolved our MLOps framework. And you can see the key enhancements here in blue. And you guys are really lucky. We're not going to do a technical deep dive on all the enhancements we made, but we'll focus in on some of the strategic improvements that had sizable impact for us. One thing that's really interesting is that we wanted an automated and a structured manner to manage our AI models in our model registry at scale. A common way to do that is the champion challenger strategy. We adopted that too. You can kind of see that at the bottom here. This lets you track the best and up-and-coming model architectures through aliasing them. And you can see that with on the red box with the aliases. But we wanted to take this just a step further. We want more traceability, and we wanted more insights. Another thing that's really interesting about this is that AI models are treated as artifacts. They live outside your code repo as an MLflow object in your model registry. So it's crucial to tie this back into the code commit. And for us, this helps bridge our gap. It helps accelerate our experimentation for more improved AI models. So with both of these ideas in mind, we landed on the core of our model registration strategy. So what does this do for us? It brings us full observability and traceability from development and even into production. What it does is it allows our teams to manage and track the up-and-coming model architectures, and also look at the best one there is right now. And this is especially important in development, where we iterate through hundreds of model versions. And the key items are shown here in yellow. You can see in addition to the champion challenger strategy, we track our archive champions. In red, we keep our offline evaluation metrics like accuracy and things like that. Pink, we keep the date. This is really useful for reservoir sampling, where your test data is continuously updating with the most recent data. And my favorite part, green, we linked in the git commit. Now, by automating this, we allow our engineers to focus on building the best models, not managing their metadata. So another component we added to the MLOps stack was dashboards for management and even deployment. What we found is that dashboards are another resource type within the DABS framework. So what we can do is we can actually define them as JSON. And by doing that, you can now manage and programmatically promote that as part of your same deployment. And when doing this, you can also assign view access to teams as well. So the whole coverage you get within this. And with doing this, our entire system is now tightly coupled, and our entire system is actually now versioned, from the models to the pipelines to even the dashboards. So for us at Vizient, we treat an MLOps framework as a living standard. This evolves with our best experience, practices, and reusable components. And our approach is super simple. If it's reusable, if it's broadly valuable, it gets promoted into this core framework, and it's very custom, or is, just for one specific project, it stays within that project. And this is true for the WebShooter project. So as we built it, we pushed the real learnings back into the core framework. You can see this here in baby blue. And with this, each project gets faster and smarter. And with this, we're also raising the bar for AI development and deployment. So we're only getting better. We also introduced another thing as well, centralized managed pipelines into the MLOps framework. Now with this, any project within our ADO group can reference a shared pipeline template immediately, just by passing a few parameters. You can see this here with 3 sample projects. For us, it's a lot more than that today. But what this allows us to do is it allows us to onboard teams faster, allows us to standardize traceability and approval controls, but also lets us propagate our updates broadly across all our AI projects. This is the second model we'll showcase today. This is the membership model. It utilizes hybrid search. So this is vector search and also keyword-based knowledge retrieval to identify and attribute spending for healthcare centers and their specific departments. The impact of this model is also fairly large, and it's actually a great example of how it further evolved our MLOps framework. When deploying this project, we encountered various architectural choices, like how do you handle vector search embedding at scale? So instead of hard-coding just one path, we made it super flexible. We made it so that we can do both single source embedding strategy, or we can also do an environment-specific one. Now, this value is technical, but it's also highly, highly strategic. By doing it this way and designing it in a flexible manner, future projects can now pick the best path suited for their system and use it immediately. This is another good example of that. But in this case, we're talking about resource optimization. So we also added a flexible approach for our endpoints to scale to 0 during off hours. So when it's not in use and it's after hours, it scales down, so there's no cost. However, it's available to scale up on demand immediately with no manual intervention. So adding this workflow into the framework lets teams apply it with minimal lift and also accelerates our deployments across projects. Another way we did this is actually by setting the standard for dashboards. So generally, when we see dashboards, when we develop them for the projects, we're focusing more on model observability. Our standard took it a step further. We enforced tabs for drift analysis, for infrastructure health, and for cost analysis on the model. And this is part of the deployment now. It's not an afterthought, and it's something we watch in our testing stages as well. It's also 2025. So we integrated an LLM to allow users and analysts to use natural language to explore the model data instead of having to write the SQL query. And you can see this here in the demo where they're looking for some trends. Now, here's where it gets exciting. After launching this AI model, another team had a very similar use case. And the data scientists were able to get their POC ready in just a number of days. And when they're ready to deploy, we'll be able to get their model to production 70% faster, thanks to all the work we put into writing the framework for infrastructure, pipeline, and standards. And this is the power of the MLOps framework that we've been developing. So with this, you should be able to get really good impact across your organization to accelerate AI development and deployment. But the question is, can you get even more impact? You most definitely can. By taking a more holistic approach and fine-tuning your AI model lifecycle, you can definitely look at where your pain points are and re-identify them as opportunities. This is a typical lifecycle here. This is where most organizations start, and we definitely did too. But you can definitely redefine the standard of success you have with your AI models by working on this. And this is where we are today. So at Vizient, we have an amazing opportunity. We work with new domain teams every single time. And this is amongst 3 to 4 different departments. So we aren't just building models. We're guiding the solutions, we're guiding alignment, and we're pushing for successful integrations across various teams. And for us, one thing that made this highly successful is the first box you can see there, the model requirements template. This prompts the right conversations earlier on for a model's purpose, success, expectations, and even risks. We use it to track scope changes, and most importantly, it's a unifying artifact that keeps the data science team, machine learning team, and our domain teams aligned. Something that's really interesting about this is just the level of adoption. The teams that have used this are actually doing this on their own before they even come to us. I mean, if that's not buy-in, I'm not too sure what is. And it shows that it works and it has impact. Another thing is that we're super selfish. We want the maximum ROI on our time. So we front-loaded all the heavy thinking. So the architecture reviews, the model reviews, and even the alignment sessions we do earlier on. And through this, you should probably be able to get really good impact and exposure.
Awesome, yeah. And as Adam was saying, we have about 20 plus projects that have AI and ML implications all the way from acquisition through the various transformation and analytic insights that are on deck right now. And so as we are going through this journey, especially the last 2 years, what we believe we have learned, what were force multipliers like Adam was mentioning earlier and accrued benefits from our journey. One of the things is we are obviously a healthcare performance improvement company in the healthcare domain, so HIPAA compliance is at the top of our minds. So we pay close attention to what Databricks features are HIPAA compliant, and the Databricks solution architects and the Databricks team constantly advises as to when a certain new offering or feature becomes HIPAA compliant, and we incorporate those. That's one. And then from a process management standpoint, for all the foundational models, we have established I would say more a process governance framework to get with our legal to confirm which ones are applicable for use. And along the same lines, we also added Azure artifacts for dependency control into our AI and ML pipelines to where any compute that needs specific libraries, they are already going through and the ability to be put into artifacts so that they are available and pre-installed for the various clusters. So what's pending in that deployment is we still don't have a process to actually block pip installs from external sources yet. So we have the ability to install from artifacts, but not block it from external, and that's something we still have left to do. And then the other two big ones was that we obviously iterated very quickly, and I would say our AI and ML platform got built pretty rapidly through trial and error over the last 2 years. And as we did that, one of the things that we took on was that we wanted to make sure that the model registry was shareable between the two platforms, between Azure ML and Databricks, and the same thing with experiment tracking. And to get all of the networking and the plumbing done the right way took a few tries, and what that did was that in some cases the resources had to be toned down and built back up. And the thing that exacerbated that challenge was that we do our infrastructure using infrastructure as code, using Pulumi, a Terraform like TypeScript infrastructure as code. So we had to also do that. And thankfully, the critical mass of AI and ML solutions hosted on these were not too great to where we could afford the cost to tear down and rebuild. So that's one thing. If we aligned on architecture early, before building all of this, we would have probably avoided some of that. And then the other one, again, this is based on our solutions and our needs. We do have an on-prem Elasticsearch cluster that our data scientists have used in some of the old solutions. And even for some of the new solutions that are primarily built on Databricks, we are incorporating that. And when we started our journey, we assumed that we would have no dependency with anything on-prem in our data center. And turns out that was myopic or wrong. And we had to, basically as part of the tear down rebuild, we had to make sure that the integration with on-prem was actually working from an isolated subscription. And so that was one thing that we learned. And then with respect to vector search, there was couple of interesting things. One was, as we did some of the LLM solutions that Adam was talking about, specifically that if the context with the embeddings, like the appropriate surrounding text or metadata wasn't sent, like in this particular case, addresses with, let's say, states that were in free text as opposed to acronyms, or giving an incorrect weight to the hospital system name as opposed to the address. All those could give you incorrect addresses, and that's more a design problem rather than anything specific with the vector search offering itself. So that's something that we learned. And then the other thing in development that the data scientists brought up to us was that as you're testing the vector search endpoint and you're adding more and more tokens, and they were basically scaling up and then ultimately settling down on the correct amounts of tokens, it was discovered that it was actually not scaling down, and we reached out to Databricks, and they helped troubleshoot the issue and resolved it for us. So thank you for that. And so I think, having said all this, we would also say that we would still iterate and experiment rapidly, because Databricks has obviously added a lot of features. Even we heard today about the GPU clusters going serverless, so which is something our data scientists would love to have access while they are developing and so on. So keeping track of runtimes, because certain features work with specific runtimes. So that's one of the things that we have 3-4 teams that are taking care of those areas for us, and we also pay particular attention to make sure that we are pretty close to the latest Databricks LTS runtime for our platform. So that's basically our lessons learned, and never stop fine-tuning. Yeah. So that's all we have at this point. We have about 10 minutes, so happy to take any questions. Thank you.
Yeah, for sure.